few minutes. Could you pause? Okay, I'll just pause it from my end and just start it when we're about to start out to write. Once again, welcome everyone. Thank you, David. David and I will be presenting the paper writing workshop today, and we'll be covering what you need to know to write technical papers, both for the deep learning projects, the class project, and also it extends beyond that to whatever technical paper you want to write. For today's workshop, we will be covering purpose of paper writing, the types of paper writing, identifying who your audience is, defining your problem statement, and then to the crux of the matter, anatomy of the research paper and other important pieces of a research paper. Like I said, David and I will be covering the workshop. We'll be co-hosting the workshop today. So I'll take the first half, and David, which is talking about the overall structure of a research paper, and David will be diving more into the technical details of the later parts of the research paper. So to start with, why do we write technical papers? Basically, to report an experiment, you want to summarize your findings. Most often it's new knowledge you're contributing to a body of knowledge, or some sort of aggregated information about historical work that has been done in different domains, related domains, or within a body of knowledge. So would usually write papers with text editors like Word. A lot of people find it easier using Word, but if you're going to be writing a research paper, academic papers, then you should get used to tools like LaTeX, because that's usually the required format for a lot of the papers, a lot of the academic papers that are submitted at conferences. And also for this course, you'll be using LaTeX to write your paper. Referencing is also important. So you should also use tools like Mendeley and Zotero. You want to make sure that apart from being technically correct, you're also writing papers that are free of grammatical errors. So you should use spell checkers like Grammarly and the likes. I don't know of any other. I personally use Grammarly, and I think Overleaf might have a Grammarly extension. I'm not so sure, but I think so. So what are the types of paper writing? We write school papers and then conference papers for workshops or conferences. School papers are basically maybe a 2-page report you write for an experiment you perform for a small part of your coursework. And then conference paper would be, or workshop papers would be reporting on like a more extensive report on, well, not as extensive as a thesis, but a deeper dive into a description of research work that you've done. And they're usually submitted to, they're usually published and submitted to conferences, presented at conferences, and maybe published in a journal. So it could be a research proposal, like I know you guys are submitting proposals due this week, by the end of this week. And in the later part of the project, you would be submitting project reports, which should be similar to the research reports that are like publishable papers. The aim of this of the project component of this course is to do work that is as close to publishable as possible. We encourage a lot of people who do good work to publish their work, and so we want to make sure that you're writing good enough papers to also get the right attention. So like I said, the papers, the research papers are usually submitted to conferences, and they're like, there are a lot of computing conferences with different styles for writing the paper, but the three notable ones are the NeurIPS, the ICML, and the ICLR conferences, and they all have slightly to largely different variations in their paper styles. So for this course, we ask everyone, not just encourage, we ask of everyone to use the NeurIPS format, which is the one to the leftmost part of my screen. It's easier to use because it's a one column like page as compared to the ICML that is you have two columns on a page and might be a bit difficult to navigate. And then for the most part, your work is centrally aligned to the center of your page, of your page. And I have linked in here the templates, the link to the templates for all these papers in case you're looking to submit your work either from this class or other works to these conferences. So we can see that the different variations between within the conference paper. So you want to make sure that you are adhering to the styles for the different conferences or workshop. Again, I repeat, for this course, we're sticking with the NeurIPS format. And then other expectations of the course for the project paper for this course, apart from sticking with the NeurIPS format, is you want to make sure that you structured your paper in accordance to the way we've described what technical papers should be like in this workshop. You also include links to your code repositories and code notebooks. If you've taken code from external sources, you also want to reference those accordingly. We don't expect that all of your code is from external sources. If you may not want to implement a baseline from scratch and use something that exists already, but you should appropriately reference those. Also, you want to reference and include licenses to data sets that you're using. Most of you'll be using data sets that you haven't collected yourself. They're from other sources, so you want to reference them appropriately. Otherwise, it would count as plagiarism. And one new requirement we're having from people this year, which we have this semester, which we haven't had which hasn't been like a strong requirement before, is groups must upload their paper to archive after the final project review at the end of the semester. So yeah, we'll be looking forward to your archive links. So going into the anatomy of a paper, before you start writing your paper, you need to know who your audience is. This allows you to know what level of details to put in your paper. I say this because oftentimes you're applying, like, say, a deep learning technique, a machine learning, or a technological solution to other domains. And so you need to decide, for this particular paper I'm writing, who are the majority of my audience? Are they more technical, or are they from the other domain in which I've applied my technological solution into? So what I'm saying is, for instance, so first of all, your audience should be people with similar background as you, or who are within the similar domain as you. And also these people should people who are looking to or should be able to reproduce your work, given that you've provided the methodology you use. What that means is that you should try as much as possible to be truthful and honest in your reporting, such that you documented all your methodology, and when people pick up your paper to reproduce your work, they're getting similar or as close as possible results to what you've documented in your paper. The other thing I was trying to say earlier is you need to make sure that, say, for instance, you are you've done research work that's applying deep learning techniques to some area of medicine. If you're presenting at a medical conference, then you want to tone it down on the technical bits and talk more of, you want to tone down on the technical bits like model description, your model architecture, and talk more of what technology generally used, how it's different from what exists, and what impacts you're bringing into the solution, into that domain. If you're presenting to a more technical audience, say like a conference on ML in health or something like that, then you want to go deeper into the technical details of your implementation, because that's what those people want to see. So you learn to tailor your content to your audience. And next thing is when you're performing a research and then writing a paper with respect to the research you've performed, there's usually a problem you're trying to solve. So you need to be able to define your problem statements accordingly, appropriately. And your problem statements must show element of new work and not just you replicating what exists already. Otherwise, that's not a research. That's not a research work. That's just a project or a reproducibility project at best. And it must also be feasible. You should be able to solve the problem that you've described, given the methodology that you want to, that you're proposing. And then you ensure that it's ethical, probably the way you're collecting your data or other methodology involved in your project is ethical, doesn't harm anyone, and is approved by a designated ethics board. So now to the anatomy of a technical paper. These are what you'd find in most technical papers, especially the three which I've previously mentioned, that papers presented at either NeurIPS, ICML, or ICLR. And so you usually start with an abstract. Yeah, the abstract is usually the shortest section of your paper. It shouldn't be more than 150 words. You could do slightly less, not too short and not long at all. And it's basically you summarizing your paper. I like to see it as it is what makes or break your paper. When someone picks a research paper, what determines if you'd be interested in the paper, in reading it, or following along with the work you've done is how you've written your abstract. So basically, it's an executive summary of the work that is done. See it as a way of you selling the work you've done to your audience, pitching yourself to the audience, pitching your work to the audience. So you're basically stating your problem statement, you state your research problem, which is the same thing as your problem statement. You're stating the contribution you've made, what kind of, given the research question, the research problem, what answers have you provided to it? That's basically your contribution to that body of knowledge. How you tested the contribution. Again, these are just like one-line statements, one to two statements for each of the points I've mentioned. And then you also want to talk about the impact of that research work, how it compares to existing solution. Also, you want to make sure that your abstract contains keyword about the research, because usually when people are searching, they search by keywords and they probably be searching through abstracts. They probably be searching with abstracts. And if your abstract doesn't contain keyword about your research, then you lost a lot of audience already. Please feel free to ask questions. You can put it in the chat. David, you can let me know if anyone has questions and I would stop to answer them. I just described what an abstract should be like, and let's step back to look at a couple of abstracts to see written. So this is an RL paper, and in this paper, I have highlighted two sections of the paper that focuses on some of the points I just mentioned. So the first couple of sentences highlights what the research question is, what they're trying to solve. And the second highlights, the one marked number 2, highlights the specific contribution that answers the research question that has been posed in the first few statements. So if you don't do anything else in your abstract, you need to make sure that you stated your research question and also the specific contribution that you've made to your research, to the research problem or to that body of knowledge. This is another paper, also an RL paper. The first couple of statements again mentions the contribution of the researcher to answering a particular question. In this case, they're saying that they're using CNN to train a variant of Q-learning, and they're trying to solve or they're trying to learn control policies from sensory inputs using RL. So they stated what they're trying to do, and they stated what they've done, saying that they use CNN to train some variant of Q-learning. And then they also mentioned how the research was tested by saying that they've applied their methods to 7 Atari 2600 games. And they also mentioned what the impact of the work is. So again, if you read the abstract for this paper, you know immediately if it contains what you're looking for, and will determine if you want to keep reading the paper or you're going to drop it because it doesn't contain what you're looking for, the knowledge you're looking to get, basically. So after the abstract, you have an introduction. Like I said, the abstract is an executive summary of what you've done, what contributions you've made towards answering the research question. The introduction, on the other hand, dives deeper. It sets a tone for the research work by giving a background, explaining what the actual problem is, starting from what exists already, the limitations of those existing solutions, and then you segue into explaining what you're bringing into the research work. So you start from a broad issue or a handful of broad issues. XYZ solution exists, and these are the limitations from it, and we would be exploring XYZ solutions. So basically, you're providing context to your research question, and also maybe stating why it's important. So a few tips for writing a great introduction would be: summarize your current understanding of the research project, what has been done till date, state the purpose of your research, and then briefly highlight the questions that your research project will be answering. So that will be in form of probably stating the limitations of stating the problems, and maybe the limitation of what exists already, and you implying that you would be looking to solve some or all of these limitations that you've mentioned. And then towards the end of your introduction, after stating that you would be answering these sets of questions with your research work, you want to briefly summarize your methodology and also state what you expect your results to be like. Bear in mind, it may or may not be that results at the end of the day, but you're starting with, we expect to see XYZ results. And then you also summarize the rest of the paper, saying, maybe in one paragraph, you then just tell us what to expect in the rest of the paper. We'll be going deeper in the literature review. We would be describing our model, and we'll have an extensive discussion dissecting different results we got and so on. Any questions so far? None? Okay. So I mentioned in the introduction that you have to talk about what the problem is and what exists already. Then there's usually a section related work. Some people call it literature review, or some other people call it background. They have different names for it. There's no set. What's usually common is a literature review, but there's no set title for different sections of your work other than the introduction and the abstracts and conclusion. You can freestyle the title of the other sections of your work. So in the related work or literature review, as you may choose to call it, you're going to go deeper into what historical work has been done or what related technique. If you're trying to bring in a new solution, you talk about, is there an existing solution that relates in a way to what you're trying to do, and how different yours will be different from that. And when you're talking about historical work, depending on the field, there could be multiple works done already in that field, or multiple solutions existing that have different variation of limitations. You want to categorize these previous works into themes, so it's easier for you to talk about. And you want to summarize those themes in a coherent fashion, not just you listing paper A said this, paper B said this. If paper A, paper B, and paper C are saying, approaching the solution from say a deep learning approach, and paper C and paper D are using a classical machine learning approach, you want to group them based off of approach and talk about them in those groups rather than just highlighting the different papers in this section. It makes more sense that way. So the components of a paper, I kind of mentioned some of this already. Components of a literature review would be to discuss an overview of the subject matter of the under consideration. And then, like I said, if you have a bunch of papers that have that share similar themes, categorize them and discuss the similarity in the approach or their differences, how they are different from each other, and what you'll be bringing that is new to all of this approach. Next thing would be methodology. In your methodology, so now you set a very good tone for your project. You've given a good background. You've talked about related work. It's time to talk about what you'd be doing. At this point, things start to get technical, right? You're free to use as much technical jargons so long as it makes sense to someone in your domain who is reading the paper. So in this section, you would be covering, you'll be describing the general approach to performing your experiment. And you must do this in such a way that it's reproducible. And also you talk about, from this section, you move on to results. One thing I want to mention is that you don't have to name it methodology. You can just dive straight into the components. And what are the components of a methodology? So you could have like a model description. So you want to start with describing, we're bringing this approach in this research work to solve XYZ solution in medicine. And we're going to be using CNN with attention mechanism and blah, blah, blah. You then want to describe your model architecture. After describing your model architecture, you then want to go ahead to talk about the objective of your modeling approach. You want to talk about, when I say objective of the modeling approach, it could be things like, are you trying to minimize the loss or maximize the reward? Briefly explain how your model architecture would help achieve that, and then use mathematical expressions as needed. I've seen situations where people, if they're using LSTMs or GRU, in solving particular solution, they would just throw in the 3 to 4 equations that represents the different cells in the RNN network. They just throw it into their methodology without it relating in any way to the work they're trying to do. If you're used to working with RNNs, you should know those equations already, but do they relate to your work? If they don't relate to your work, then you don't need to use those mathematical expressions. But try as much as possible to interpret your model description into a mathematical expression as needed. And then on the methodology also, you want to talk about the data you're working with. So if you're working with, say, speech data, you want to talk about the type of the data. In that case, it will be speech data, image data, or maybe 3D data, 3D point cloud data if you're working with 3D images. And then you also want to talk about what kind of mode it is. Are you combining multiple mode of data, or is it just a single mode? So a multiple mode of data, a multimodal data data set would be probably you're trying to generate text subtitles. Yeah, subtitles is what you're trying to generate subtitles, and you have audio data and images. You're feeding audio data and images into your model or your system to be able to help you appropriately or accurately generate your subtitles. In that case, you're using a multimodal approach. So you want to clearly state that you're following the multimodal approach and XYZ type of data is what you're using. You also want to state how the data set is collected. I like to use the example of performing robotics experiments. If you're performing a robotics experiment, you could either collect your data through real life robots, operating real life robots, and taking readings, whatever readings, say the robot arms pose or other movements of the robots. You collect data that way. Or you could do simulations with, say, the Unreal Engine and capture the readings that you want. So you need to state how the data was collected. If you're doing any form of pre-processing, you need to mention that. And if you haven't done any of this step, that's okay. If you didn't collect the data yourself, and you didn't pre-process your data, or you didn't do the earlier stage of pre-processing yourself, that's okay. You just need to reference the source of your data, right? And also if it's like you generated synthetic data, maybe because you don't have enough data, you should also state that. And then you should talk about the characteristics of your data, how you're splitting your data. So basically describe the data, say the length of the data, how you're going to, are you splitting in an 80-20 approach or a 60-40 approach or whatever, and why. The next thing would be, still under methodology, you should discuss your baseline and evaluation metrics. So your baseline should be, the baseline is sort of like a solution that exists already, or a combination of solutions that exist already, and you believe that your new solution is better or will be contributing more to the baseline, to improve the baseline. So first of all, you need to make sure that you're selecting a competitive state-of-the-art baseline. And you also need to consider, one of the things you need to consider is, are you implementing this from scratch, the baseline that is, or does it exist like, say, a library or in some format that you can import into your code? If the latter is the case, then you'd have to properly reference the baseline. And then also bear in mind that you would be comparing the baseline. The essence of the baseline is for you to be able to compare with your results from the new work that you've done. So how do you compare these? You need to have some metrics that you'll be comparing with, and your evaluation, those are called evaluation metrics, and your evaluation metrics would vary from project to project, right? You need to be able to define your metrics properly using mathematical expressions or describing them in a way that makes sense. If you're trying to predict, if you're trying to generate subtitles, so you could be using things like word error rates. There's a formula for that. You need to put that down and articulate back to your audience why it makes sense to use the word error rate in as an evaluation metrics. You also so the reason for doing that is to make sure that you're showing to us that well, at least within the context of this course, you're showing to us that you're demonstrating that you understand how the metrics work. So you explain your metrics and you use a mathematical expression to back it up if it has one. And yeah, so that's really what the crux of your methodology is. Make sure that you're defining your model, you're describing your data sets, you're talking about your baseline and also your evaluation metrics. I would stop at this point and hand over to David, who will be taking us through the rest of the recitation. There are no questions. David, are you there?
Yep. Okay. So I'll share my screen. All right, can everyone see my screen?
Yeah.
All right, great. Okay, so we'll go through, having gone through the abstract introduction and method section, what's left are the experiments, results, discussion, and the conclusions. So we'll go through these components. So the experiment section should contain a lot of details about the hyperparameters used to train your model, how the data set was used, and the evaluation metrics you used. So standard is to report metrics in comparison with other work. And what's important here is to report and compare with other works under the same settings or similar settings. Otherwise, if the other works have used a suboptimal setting and then you optimize it a little bit, perhaps the improvement you're trying to say is not coming from your actual method, but the other settings that you tweaked. So make sure to report under similar settings, and if necessary or even possible, run multiple times and report standard deviation over your runs, because neural networks are inherently stochastic and every run will have different results. Another key component, I think this is one of the most important parts of the paper, is the ablations. When someone reads the paper, or when I read a paper and I'm not necessarily too familiar with the work and the state of the art, I don't necessarily really focus on your comparisons with other works. I want to know whether what you propose is actually useful and bring performance gains. And that's what the ablation studies are for. So you proposed a couple different components. This paper on the left proposed 5 different components, and we're curious to see how much each component actually contributed to the final performance. And the way you would do that is, well, with an ablation study. So you start with the baseline model at the first line, then you add each component one by one. So they added this thing called sub-pillar and then found performance gains. You can look at the last column here, 2-point performance gain. And then they add PE, another performance gain, and so on. So this is probably one of the most important parts of your paper, since it illuminates how much each proposed component actually contributed. Another thing to keep in mind when doing ablation studies, or even just developing a model in general, is you have to consider relationships between components as well. Sometimes it's the case that each one can lower performance, but in conjunction, they can boost performance. And one example of this that you might actually run into during your homeworks is, let's look at this part. So this paper is just looking at different like training parameters and training ResNet. And they find that adding dropout on the fully connected layer decreases performance by 0.3%. And that seems odd to us because that should help with overfitting. However, they find that after they add dropout and then decrease the weight decay, the performance actually improves by 1.5%. And that's because dropout and weight decay are both regularization methods, and having too much regularization can hurt the method. So increasing regularization through dropout and decreasing regularization through decreasing weight decay gave them a resulting performance improvement. So it's important to consider how different components interact with each other as well. All right, so next is the discussion section. Discussion doesn't necessarily need to be its own section, but it should outline the overall takeaways from your work. And often these takeaways are fused in with the results and ablation sections. And you do see some works putting their own discussion section in the paper, and that's usually if they want to convey some kind of intuition about their works or want to delve into why they think their method works, and etc. And now the conclusion section. So the conclusion section, as you might be aware, is just a summary of your paper, summary of the work done. It reiterates the fundamental research questions and findings from your work that answers the question. So perhaps you set out to solve some problem that you noticed in other works, or you noticed a gap in the current research and you propose a solution to close that gap. The conclusion should drive it home that you did indeed successfully complete what you set out to do. And you should also highlight what possible shortcomings of current work there are, if there are any areas for improvement, if you're considering any next steps or future works to build on your work, and possible extensions for this. And this, in addition to just being truthful about your own work, also adds another layer of subtlety to your work, that you did indeed think about these questions on your own, and you do understand the field, that can give reviewers more confidence that you know what you're doing and your work is valuable. And references, of course, you need to add references. The bulk of your references will be in your related work section, but any paper that you think is related, even marginally, should be in your reference section. And these are some styles. You should just follow whatever NeurIPS recommends. And so we did go through all the components of the paper, but there are other overarching themes that are good for you to keep in mind. And these are things that reviewers will look out for and will increase your chance of getting a good grade or acceptance. And these are reproducibility, having good story or narrative, general points, and then some points outlined in this meta work, Troubling Trends in Machine Learning Scholarship. So first is reproducibility. When writing your paper, you need to ask yourself, if I handed this paper to someone, can they reproduce my results just using the paper? And the answer is no. And the answer might be no because of just implementation tricks, hyperparameter details that aren't necessarily worth mentioning in the paper, but just are important to getting the model to work. You need to release code or add extra details in the paper or the supplementary for other people to successfully reproduce your work. And that's important because if your paper isn't reproducible, you'll get emails from people seeking to build on your work or compare with your work. The paper won't be cited because people read the paper, try to reproduce it, get poor results, and then just decide not to cite it. Or the next paper will cite your work and say, we could not reproduce the results of your paper, which is arguably worse than not getting cited. So reproducibility is very, very important. And one field where this has emerged as a particularly important problem is RL. RL is, well, machine learning is very stochastic, but RL is more so because there aren't, for most work, there aren't explicit gradient signals coming back from the loss or the reward. You're basically fumbling around until you chance upon a good solution from after which you can start to learn. And because of this, in RL, there are a lot of miracle runs, as I would like to call them. Something doesn't work for like 10,000 iterations, and then suddenly one run, the model chances on the correct solution and then improves very early, very well. And there was a lot of discussion around RL literature works not being reproducible because people just report the single miracle run. And then when other people try to reproduce it, obviously they can't get this miracle run. And then they're like, this paper isn't reproducible. So what you need to do for RL and other works is if the performance is unstable, you should report average of multiple runs and show standard deviation error bars as shown on the left here. So you see this faded region around the actual model, around the core result, indicates instability. And that should make your paper more reproducible in the sense that it tempers expectations about your paper, and then it's a more truthful and honest recording of your results. Another key part of your paper is having a good story or narrative. So this might be the most important part of your paper. And that's because you can have good results, but that if they aren't grounded in the overall narrative or the story that you're trying to push, the results on their own don't mean anything. So maybe you improved classification on some data set by 1%. And maybe that's actually a very important or huge margin on that data set. However, that on its own is just a numerical improvement. You need to tie that into like existing works miss this key component of classification that we address, and that makes our model more interpretable in addition to improving performance or something like that. Something that drives home the intuition of your work and makes your reviewers convinced of your work. So I listed a couple examples on the right. Is there a point existing works have overlooked that you consider? Does previous work fail in certain cases, perhaps low resources, certain classes, that your method is inherently better suited for? Can you relate your work to some core intuitive notion that will give readers an aha moment? And some examples of that off the top of my head would be, I guess, attention or transformers in recent works have gotten really popular. So maybe you would say that, or some works have said that transformers in vision don't necessarily need to attend over the entire image, which is very computationally expensive. Since nearby pixels are inherently more related to each other, maybe we can restrict models to only looking at local regions. And that would be like an intuitive aha. Maybe that would actually work, that you could push your paper through. And another thing to note about this is, even if you have weak results, if your story is strong, so if your weak results can be framed in a context where it's actually not that weak and rather important to the literature at hand, that can improve your chances of getting accepted. So the story is very, very important. And some other general points. So a research paper is an argument in support of your work, not just a technical report or a list of observations. And you should aim for the goal of the reader should be convinced that your method is better than existing work. So through a research paper, you want to make an argument that your method is good and other methods are bad. And if the reviewer or the reader isn't convinced by this by the end of the paper, you need to go back and revise and reframe your argument and reframe your research paper to be more like an argument. Try not to make up your own technical terms or make things seem unnecessarily complicated. And I do get where people are coming from when they try to do this, because they want to add another layer of complexity or like technical contribution to their work. But a lot of people will see through this, and although it might seem cool, it will confuse readers or annoy ones who are not awed by this technical term. And an example I thought of was, you might write, we extract complementary semantics via feature entanglement over space and time. Okay, that sounds cool, but what does it actually mean? You want to distill that into, given RGB video, we run a first CNN over the temporal dimension and run a second CNN over the spatial dimensions, and then combine the results. So these two are supposed to mean the same thing, but you can clearly see that the second one doesn't use these language like feature entanglement over space and time, and rather is more clear and direct. And when someone's reading your work, they want to get the core intuition as quickly as possible. And this first example rather inhibits them from doing so, from being able to do so. All right, this is a meta work that looks at machine learning literature. And this is actually a paper from 2018 that has been trending recently. And it details some common/bad trends in ML papers that impede understanding and add noise to research through research papers. Just to go through these so you can avoid them and get an idea for what good practices in writing papers are. First, explanation versus speculation. Papers should make explicitly clear what is formal reasoning and what is informal speculation. And what that is, formal reasoning would be stuff that's supported by theory, so proofs or experiments, And then informal speculation would be you looked at your results and then you have some intuitions or like speculations for why those results might be happening, but it's not actually supported by hard theory. For instance, internal covariate shift that you guys might be familiar with through Adam is not clearly stated as an informal speculation and has rather been repeated as fact when it could be false. So going through the actual paper, there's no proof for internal covariate shift. Instead, they have this kind of pseudo proof that lends or that kind of seems to support the existence of internal covariate shift, and they report this as fact. And that's particularly harmful because Adam itself is a very strong method, regardless of whether or not internal covariate shift is a thing. So it got tens of thousands of citations, but there are a lot of recent works looking at internal covariate shift and saying, actually, what they initially proposed in internal covariate shift doesn't actually happen. And Adam instead works because of so on, so on, so on. So clearly delineating between what explanation and what is explanation and what is speculation is very important. And as positive examples, other papers sometimes quarantine a motivation section for informal intuitions. And it's not that speculation is not helpful, because speculations guide our development of our methods and guide understanding of machine learning models. But they should be clearly separated from theory, so other papers that look at your work don't take them as fact. Failure to identify the sources of empirical gains. So this also links into ablation studies. And then the heart of the problem here is that when you're building off of another work, you might often find that their hyperparameters or other settings aren't very strong. And you might find that adjusting the learning rate or adjusting other parameters results in a performance improvement on the original work. And then after that, you would propose your own modules. However, you need to decouple improvements from these hyperparameters and improvements from your own modules very clearly. So some papers do not clarify the sources of gains in performance, and follow-up papers have found that actually hyperparameter tuning was the more important factor. So paper B might report a 10-point gain over paper A. However, they find that 8 points of that 10 was from hyperparameter tuning and 2 points were from the actual method. Or in even worse examples, 12 points were from hyperparameter tuning and -2 points from the proposed modules. And you don't want to do this because later papers will find this and debunk your paper. Misuse of language. So this is probably another level of meta on top of just writing papers. But some works define equations or ideas in a manner that imbues them with human level priors such as curiosity or fear. So what I mean by that is in RL, okay, I guess I'm pointing out a specific example, but this did have a lot of discussion online and in person. So in RL, there's a series of papers that talk about curiosity-driven learning. And the reason they frame it as curiosity is as part of their reward function, they encourage the model they reward the model for getting to places that they haven't been before. And they basically formulate this through, I believe, something Kale. But to not get into the details, they frame this as curiosity because they're like, hey, the model is curious. It's looking for places it hasn't been before. So that relates to our human notion of curiosity. However, this is dangerous because the word curiosity, when applied to humans, has its own associated feelings or like intuitions. So curiosity for us isn't just about seeking out new things. It might be about thinking about new concepts just because we're fundamentally interested in them. However, calling an RL that just explores new things curious subtly influences this thing that it has all these other human level positive properties, which is very dangerous and frankly not true. Because you would observe that curiosity spends like 10,000 iterations just jumping off of cliffs because it hasn't died before and so on. And that's not a human notion of curiosity that we expect humans to have. What the agent learns is not necessarily the human notion of curiosity. Using anthropogenic terms gives laymen unrealistic expectations about AI. And just beyond your work, or just beyond your research paper, it gives people outside of the field unrealistic expectations, which just isn't good for your paper and isn't good for the field. So you should use more technically grounded words instead of notions such as curiosity or fear. And yeah, I think that's all the various components of a research paper. We outlined the various components such as the abstract, introduction, methods, experiments, and conclusions, as well as some overarching themes about the research paper that you should keep in mind. And yeah, so if you have any further questions about this, you can post on Piazza. So thank you for coming to Recitation. Or if you have any questions right now, you can ask.